Good morning, everyone. Welcome to all participants. Let's begin maybe 5 minutes past 10, just to give everyone some time to settle in and give a small buffer period. Please start your kettles, make a cup of coffee, get comfortable. Hopefully your devices are set up properly. You have your phone ready as well, and it will be a productive meeting. This session will be recorded as well, so if you want to refer back to it or send it to another person of your network who couldn't make it, then you can definitely let them know that there will be a recording that will be sent out in due time. So currently we have 39 attendees in the webinar joining us thus far. As mentioned already, we will wait maybe 5 past 10 to give some people some time to settle in and organize themselves. Just for the purposes of testing, Andrew, I've unmuted you. Can you just confirm audio and visual is clear?
Yep.
Perfect.
Quite clear.
Amazing. Perfect. Thank you for that. So now we're at 60 attendees in the chat in the webinar. So good turnout so far. We'll give a few more minutes and then we'll get started. Any questions, feel free to post in the chat function of the webinar. All of you are free to do so. But there'll be plenty of time as well with the Q&A sessions and some other things I can organize for you guys to interact with me. Just to get a gauge on our demographic of attendees today, can you just type in the chat what is your job responsibility in your respective company? Installer, designer, sales, management. Thank you, Duncan. Amazing. So I see a lot of installers in the chat. And this is good news because this webinar will not only just be a technical training, but also it will accrue CBD points. It's currently in the approval process with the SAA. So it is being assessed in real time right now. and it is due for 20 points. So it is the maximum points you can get. It is a core subject. So you can rest assured there won't be, too much corporate or sales content here today. It will be purely value-driven information and technical training for you guys. Amazing. So I see a lot. Businesses, designers, installers, management, directors. Fantastic. I see majority installers, which is really great. Luke, if you check the SAA's website now, who's the new body for accrediting design and install accreditation license, the points now, the maximum they go up to for new courses are 20, unfortunately. You can double check that on the website. However, existing legacy courses, I believe they are still able to hand over to the SAA with the 30 points they had before. So I think that's what's going on. Existing courses with 30 points still have the 30 points. Any new courses that need to be applied for will go up to a maximum of 20. But I will negotiate with them because I do believe this training is information dense and it is worth 30 points for sure. Okay, guys, so now we're at 70. We'll give 2 more minutes and we'll get started. Just a reminder, have your phone ready as well, as there will be some interactive activities that we have to do throughout the session. Jake, I think it's 20 points based on SAA's matrix table for new applied courses. I'll double confirm that. If I can negotiate the 30, I will do that because I think this course deserves it. And it'll be better for you guys, obviously. All right, good turnout, guys. So without further ado, I'll begin the webinar. Let me go ahead and share my screen. And Andrew, if you could kindly again confirm everything is viewable. Is my screen sharing properly?
Yep.
Great. So let's get started. So guys, just a quick intro. My name is Ramsey Shamali, Technical Sales Manager for Suntech, looking after Australia and New Zealand. Why am I qualified to do this training today? Well, my background is renewable energy engineering at UNSW, and have been working in the industry now for about 7 years throughout the rooftop and utility segment. So hopefully today I can bring some value and bring you some newfound knowledge and this topic for today, being designing with bifacial PV modules. So let's begin. This will be a 45 to 60-minute session. And as I mentioned before, it will accrue CBD points for your professional development. And I look forward to presenting this to you guys. So thank you all for joining me. So the objectives of this course are as follows. I want you guys to understand the technical characteristics of bifacial PV modules. I want you to correctly identify scenarios where bifacial gain is relevant or not relevant, the ability to accurately model, simulate, and design solar PV systems with bifacial modules. I want you to continue, of course, to comply with all the relevant national and regulatory body standards when using PV modules. And also, it's really good to understand the technical and commercial implications when using bifacial modules. And lastly, how to correctly identify performance increase for energy yield and financial returns. So why do this course in the first place? What's the relevance to everybody in the field and in the market? So basically, according to ITR-PV, International Technology Roadmap of PV, and many other industry reporting bodies show that the market share now of bifacial cells as of today is 75%, and downstream from there, the modules are 40%. So in the industrial chain, the production is predominantly now bifacial for both the cells and modules. And as you can see in these column graphs, in the next couple of years, it's forecasted to absolutely dominate and become much more than 50% of the market. So this represents an industrial transition of PV module manufacturing design from the single glass to dual glass. And it's a similar shift to what we saw previously for the cell technology transition from PERC to TOPCon. So similarly, we're experiencing that for monofacial to bifacial. And this comes after half a decade of field data, utility solar farm projects, and case studies. It has demonstrated that there is a gain of energy to be made, ranging from 5 to 20%. So you guys, the installers, are the backbone of the industry, and it's really worthwhile being aware of bifacial characteristics now as it comes into more relevance to our applications now in the rooftop market, as for the mentions I just mentioned. So bifacials is lost my train of thought. Well, let's just go on to the course objectives first. So today, these are the chapters I will be presenting. What are bifacial modules? Factors which influence them, regulation and standardization for the modules, some software tools that are relevant, practical instances of bifacial modules, and then, of course, Suntech's tips to navigate the rooftop market with bifacial modules. And we'll do a Q&A at the end. So what are bifacial modules? PV modules, they are PV modules that are two-faced in the context of receiving light. So some physical prerequisites to be classified bifacial is having transparent or clear backsheet, rear glass substrate in substitute of the polymer backsheet, or any combination of the above. And furthermore, the cell technology must be more advanced than aluminium back surface field, which is a cell architecture which is monofacial in design. The backside is full metal contact. So all of this includes PERC, TOPCon, HJT, etc. So pretty much everything on the market now is a technology which is bifacial. So I just put a little graphic there of the installer. So if you know any installers who are two-faced and tell you one thing and tell someone else the other thing, then you can call them a bifacial solar installer. I know, a very good dad joke. So physical appearance, obviously the bifacial modules will be transparent. And on the rear side, you can see the cells as you would on the front. Monofacial counterpart is just simply a oblique back sheet, as you see here, the white one. And in the sample here on my desk, this is like a traditional solar panel, how it looks like on the back. So we're moving from, polymer white opaque back sheets to now transparent and real glass design. So the anatomy layers are as follows. Monofacial and bifacial, what are the differences? Simply, the bifacial version replaces the traditional polymer backsheet with a rear glass layer. Everything up until there is the same. So the frame, the glass on the front, the encapsulation on the front, clear, obviously. The solar cell is the same. The rear encapsulant also will be the same. And then the last layer, but it will be a backsheet in the monofacial, but in the bifacial, it will be replaced and swapped to a rear glass layer. And that gives it its transparent design inherently, organically, right? So some applications that we are aware of in the field: flush mount resi, carports, flat roof tilted leg systems, and ground mount. All of them have kind of a bifacial utilization score based on how well their potential is to capture sunlight on the rear side for bifacial gain. As you can see, I've scored the flush mount resi with 1 star out of 5. This is mainly due to its ability to capture rear light is limited due to it being flush mounted. So, no ground clearance, no tilt angle to its mounting surface. So yeah, the rear side is completely obstructed by itself. Therefore, no light can get there. Carports, on the other hand, they are elevated, they're above the ground with some height, and therefore there is potential for rear side gain. Obviously, flat roofs are installed with tilt leg racking systems predominantly because they need to be tilted to avoid, being installed flat, which most manufacturers don't warrant due to obvious reasons. And similarly with ground mount, you have either fixed tilts or um, tracker systems, whether it be single axis, dual axis, horizontal, or portrait. And all of these have a good utilization score because of having the rear side more visible to sunlight. There is some confusion in the industry. There is double glass products, but they're not bifacial. So what does this mean? Dual glass does not automatically translate to bifacial. There exist products on the market which are dual glass, but not bifacial. The reason for this is they have utilized a white opaque encapsulation layer on the rear. So normally encapsulation, the EVA or POE, which is the normal material used, is clear traditionally. So we don't even think about it. But it is an existing layer always between the cell and the glass, or the cell and the back sheet for the rear side traditionally. But for these new products like our NSHKM Plus model or other products on the market you can see from other manufacturers, when it's dual glass but it's monofacial product, it's because yes, it has dual glass, but on the rear side behind the cell, there is an encapsulation which is white. Hopefully that clarifies it. So a product can be dual glass, but not bifacial. But it can also be dual glass, but bifacial. So dual glass does not automatically mean bifacial, but bifacial does automatically mean it's transparent. Now some notes on electrical rating for bifacial modules. So manufacturers historically provided separate tables for bifacial gain, and they normally quantified it in three ways that we've seen from reference data sheets, such as the following here. I've put one of ours, Suntech's, I've put an LG one, I've put a Phono, Hyundai. All of them might have slightly different ways of reporting their electrical output for the bifacial gain scenario. So there is one method of doing, simply percentage, and it's as simple as taking the STC value and just multiplying it by the percentage. It's that simple. Other methods is like LG they did before, showing the electrical output for a specific rear irradiance, whether it be 100 watts per meter squared or 200, like they have done so here. And the third one is BNPI. So this is just one rating for a specific rear irradiance, which I will detail at length later. And this is done by some manufacturers as well. Now, guys, it is time to take out your phones and scan the QR code, as I would like to quiz you at the conclusion of this first chapter. So hopefully your phones are in reach. Once you scan the QR code, you should be able to join. So Andrew, can you also confirm, please? I see on the screen already, people are joining. Great. So I'll just give a bit more time. Wow, so everyone is joining now. That's great. So let's get started, guys. Maybe 5 more seconds. All right. First question. I'll let you guys read through it and answer. You got 15 seconds. Go. All right, that time's up. Everyone has made their answers. So majority say all of the above, and that is correct. Well done, guys. Next question. Sorry. So we have a leaderboard structure here. So well done to our top 5 so far. And this is based on how fast you are as well. Good work, Troy, Marcus, Max, Brendan, Nicholas. Next question. Go. 20 seconds. All right, time's up. So everyone answered majority of A. It was B. So in bifacials, they have replaced the polymer backsheet layer on monofacial with a glass. Maybe you didn't read it correctly, but yeah, this is the primary answer. Answer A, it doesn't really have a backsheet at all. So it's kind of a trick question. So it's not correct by saying bifacial has a clear backsheet. All right, so leaderboard structure shifted. Here is the current standing. Next question. 15 seconds. All right, time's up. Everyone, majority answered A, which is correct. Well done. Bifacials, well, of course, cooling does determine and influence the performance of modules, but in the interest of bifacial gain, this is the primary factor. Well done, Max. All right, next one, 15 seconds. Correct. Everyone answered C. Majority is correct. Well done, Brandon. Now in first place. Okay, guys. So now let's move on to the next chapter. So what are the factors which influence bifacial gain? There is a myriad of factors. Let's go through them and unpack them, shall we? So first one is the bifaciality factor of the module. So simply, I know this slide is overwhelming, but just hear me out. It's a decimal from 0 to 1 fraction, which describes the module's ability to generate power on the back side compared to the front side. So it's simply a division calculation of the max power on the rear side versus the max power on the front side given the same condition, STC, for example. So when a bifaciality factor equals 0, it just means it's monofacial product because the power on the rear side, no matter how much light you shine on it, it will be 0, of course, because of the opaque backsheet. So 0 divided by anything is 0. However, for bifacials, there will be a factor between 0 to 1, depending on how well the backside generates power compared to the front side. Naturally, it will always be never equal to 1, and it will be always below it because of the self-shading elements caused by the J-box, cabling, the frame, right? Naturally, it is not the primary side to generate power, so it has these obstructions by nature, by its build. So yeah, but most modules these days, as you know, half cut, 3 junction boxes in the middle axes of the panel. So they all exhibit the same kind of rear side design. And so therefore, the bifaciality factor will be determined primarily by the cell technology. And now at the bottom of this slide, I'm just showing you like a simple illustration of what bifaciality is. So for example, in this case, Pmax rear is 500 watts measured divided by the front side at STC 620. So in this scenario, the bifaciality factor will be 0.8. Now, extending on from this slide, I've just demonstrated here from left to right different cell technologies and their respective bifaciality factors. So as you can see, they range from as low as 0.65 or 65% to as high as 85% on average. And despite the next generation technology of back contact cells and their enhanced efficiency compared to other technologies, they in fact have a downside, which is their bifaciality factor is pretty low. And this is mainly due to their optically obscured rear side because of both the positive and the negative electrodes is now on the back side. So there's just more optical obstructions, right? So naturally it suffers in that avenue. Next up is PERC at 70%, TOPCon at 80%, so slightly better, and HJT just a little nudge better at 85%. So these are the primary factors which influence the bifaciality factor. So even without looking at a data sheet, if somebody tells you I got a TopCon panel, and they say, what's the bifaciality factor? You don't even need to look at the datasheet. You'll know it's 80%, for example. The next factor, which is very, very important, is the ground albedo factor. So albedo simply is also a number from 0 to 1, quantifying the fraction of incident sunlight that a surface reflects. So therefore, the higher the albedo, the more reflective of sunlight a surface is. So the easiest way to use albedo values is to simply cite them from reference tables online, as seen below. And the spectrum of albedo values range from as low as 0.09, which is representative of black asphalt, to as high as 0.9, which is like something like snow. So naturally, black surfaces absorb, and light surfaces reflect. So this is in agreement with this kind of general knowledge concept, right? And all online reference tables are pretty much in agreement with each other. So if you just simply Google it, and the first one you find will be fine. You can reference that table. So you can see it ranges for a myriad of different surfaces that are relevant to us in the field, whether it be grass, asphalt, concrete, soil, ice, wherever you may be, you use the relevant value for your installation. The first method is just citing values from reference tables, which is fine and normally quite accurate, obviously. However, if you want to go a step further and do some other measurement to verify it on your site, you can do this albedo measurement via irradiance measurements. So you can either use a pyranometer or a fluke irradiance meter, which some of you might have as installers, and you can measure the global irradiance from the sky. So you just literally face the sky with your meter, take a measurement of the irradiance, watts per meter squared. Then you do another measurement facing the ground of where your panels will typically be installed. Make sure you stand at least 0.5 meters above the ground. You don't want to be too close to get a more accurate measurement. And you just divide the two. So you divide the one facing the ground by the one facing the sky. This will give you a good, accurate albedo value. And you can walk around the site and do different measurements to make sure they're all in agreement with each other. Right. Next is irradiance. So as we know from computated weather data, we are provided 3 different types of irradiances that we can work with. GHI, which is global horizontal irradiance, depicted in yellow. DNI, direct normal irradiance, depicted in green. DHI, diffuse horizontal irradiance, depicted in blue. So all these are just different types of irradiances that are relevant for our power simulation of PV module output, right? And simply global horizontal is the sum of everything hitting a horizontal plane. Direct normal is a direct beam of irradiance hitting a plane perpendicularly to it. So that is the maximum irradiance that it can be beam. Anything away from 90 degrees will slightly be lower and lower due to the trigonometric factors. And diffuse horizontal radiance is obviously any scattered, sunlight hitting clouds, hitting obstructions, hitting other things, and finally making its way to the surface after being scattered. So to get these weather data and irradiance values for your particular site, when you want to either measure the most extreme day in summer, or whether you just want to get an understanding of the site's irradiance levels, there is actually the best place to do it is on the NREL website. I've placed a link in the slide here. I'll give you a copy of the PPT also after, so you can directly access it. But I mean, these guys are providing weather data from many different, they're not directly providing, but they're citing a resource for all the different vendors, right? On the left-hand side, you can see these are all free options, so you can directly download it for free. On the right-hand side table, this is showing some paid weather data downloads. And some of them you might already be familiar with, like, Solcast, SolarGIS. They're all pretty popular in our industry, and they might have more precise and accurate data. That's why it's paid. So the resolution of the data may be more accurate. And here's just a heat map of solar resource potential all over the world and the globe. And quite proud to see Australia has a really high resource. So this is probably another reason why industry is very, very leading in the forefront of PV adoption and have one of the highest PV installed per capita, right? All right, so another important one is ground clearance. So this must not be overlooked. So generally, it's defined as the distance between the ground and the lowest hanging part of the module. So for a flush mount rooftop system, this ground clearance is pretty much zero. It's negligible, right? Because it has no tilt. But for a flat roof system or ground mount systems, you can see there is a ground clearance. Obviously, in flat roof systems, you're constrained to the height or the racking system you're using, right? So whether it's a tilt leg system or Clenergy or whatever brand you're using, it's generally fixed, the ground clearance. You cannot modify it, or perhaps you could, correct me if I'm wrong, but generally you don't want to like make it too high, otherwise it looks kind of unaesthetic and it doesn't sit nicely, and also it could affect the wind load pressure profile on the array. But the message here is the more ground clearance you have, the more bifacial gain you can make, up to a limit of around 1 meter is kind of the threshold. After that, it kind of plateaus, and any more elevation is useless, right? So that's why generally in ground mount systems with the tracker systems, you can see they're about 1 meter high. This is all you need. You don't need any more than that. So, you know, the more you can do, the better. You know, for example, if you compare 10 centimeter to 30, you can see about 2 to 3% gain. So it is something. Now, tilt angle is another one we're already familiar with, whether it's monofacial or bifacial, right? There is an optimal tilt for any geographic location in the world. The rule of thumb normally is to match your tilt angle with your latitude location value. So here in Sydney, for example, is minus 34 degree. So that means 34 degrees roughly is the optimal tilt angle for maximum year-round yield for, I believe, a typical north-facing system, okay? For bifacial, however, this changed a little bit for scenarios where you do have a very high albedo surface. So you already know what albedo is. So if the albedo is high, then the optimal tilt angle for bifacial shows with studies from NREL and other institutions that it will be maybe about 10 degrees higher than the optimal tilt for monofacial. So in this diagram here, you can see for two different for monofacial versus bifacial, the optimal relative energy yield for the peak for monofacial is about 35 degrees. The peak for the bifacial is 45 degrees, so 10 more. And this is logical, right? The more visible sunlight is from on the rear side of the panel, the more it can absorb and more incident rear radiance is available to the panel. So this is the reason for that. However, if the albedo is not very high on the side, whether it's like it's like a very dark concrete or something like that, then you can simply use the same optimal tilt angle as a monofacial. Otherwise, there won't be much gain. Module transparency, it's another factor, not to be overlooked. It's defined as how much light passes through the transparent gaps between cells and the frame perimeter in the module, right? Now, bifacial panels, they have transparency because of the gaps between the cells, and there is no backsheet anymore. So light gets through, and for general products on the market, it's in the range of 2 to 5%. So this is something to keep in mind, and the softwares that are accurate will request this parameter as an input. Sun's position is kind of an indirect influence on bifacial gain because we use the sun's position for other things, such as for flat roof systems, we use the sun's position for inter-row spacing calculations. So normally, correct me if I'm wrong again, rule of thumb is to space your rows based on winter solstice day of the year, and based on its elevation angle of the sun, you use that angle to calculate inter-row spacing. So there's a fantastic tool online on PV Education. You just plug in your longitude, latitude, time of the day of the year, which I just mentioned. Winter solstice is the 21st of June in the Southern Hemisphere, which is where we are. And it will spit out all these different output sun angles. And the one we're concerned about is elevation. Right, so Even in this screenshot, I have done the winter solstice day for Sydney, and it shows elevation of 33 degrees. So that means when you stand and look at the sun on winter solstice day, 21st of June, the sun will be 33 degrees high in the sky. So that means this is the angle we use to calculate inter-row spacing. And you guys already know how to do it, but this is just a quick refresher. You just need three parameters: the module length, the tilt angle of the module, and the elevation angle, which I just described in detail now. Once you have those three, it's quite simple. Module length times sine of the tilt divided by tan of the elevation, and you get it. Perfect. Also, I put in some other formula here, which takes into account tilted systems on already tilted surfaces, right? So you might have a very shallow pitched roof where you also want to implement a tilt leg system. Then you have to use this longer formula, which takes into account the pitch of the roof you're installing on. And whether it's pitched negatively or positively, depending on which direction it's facing, it's a north-facing pitch or south-facing pitch, you use these respective formulas, right? You just flip the angle, flip the sign of your pitch angle. Now, also, it's worth noting there is also more losses in the rear because of the mounting systems, whether it's the torque tube on a tracker system or the rails and legs on a tilt leg system, right? So this also affects the output, and some software takes it into account, some don't. So you need to be aware of this as well, that what assumptions are made. IAM losses is incidence angle modifier. So obviously, the more shallow the angle is hitting the interface surface, the more chance it will reflect. And this needs to be taken into account as well for the rear side incident sunlight. So you need to make sure also that your software that you're using takes this into account to be very accurate as well. All right, that concludes the chapter on factors which influence bifacial gain. Let's refresh the memory and see if you guys are ready for the quiz. So please, again, scan the QR code and we will begin this next set of 4 questions. All right, guys, are you ready? Or have you scanned the QR code? Is it working? Can Andrew let me know, please?
Yeah, I have joined.
Perfect. All right, 15 seconds. What is the bifaciality factor for TOPCon cell panels? Time's up. Let's see. So everyone is answering majority 0.8, and you are all correct. Well done, guys. Let's check leaderboard. Is it still the same person? I think so. All right, next question. Which statement best describes bifaciality factor? 17 seconds, go. All right, excited to see the answers. And majority have just edged the correct answer. So the correct answer is indeed B, the ratio 0 to 1 between the rear side power output divided by or versus the front side. So well done, guys. This one was more of a question of how well you read the answers. Well done, guys. New leaderboard here. What is one of the most important factors which influence bifacial gain? Let's have a look. And everyone answered ground albedo as the majority. And that is correct. Well done, guys. So yes, it's all about ground albedo because this is the resource of light that can touch the rear surface. So if you have a really high albedo, it's a very high potential of light on the back surface. Philip, Nice job. 6 out of 7. What is the optimal ground clearance for bifacial gain? So this is just approximate, of course, but which one is the most optimal? 3, 2, 1. See what everyone answered. Hopefully they're, yep, you guys definitely are correct. It's 1 meter. Now, let's move on to the next chapter, which is quite important. So what is the regulation and standardization for bifacial modules? Currently, there is 4 different standards which have relevant clauses and reference to bifacial modules, giving more information about them. So this includes the 2 primary, standards for PV modules, which we're already aware of, 61215, which we've had a new version been released recently and giving us some more headaches recently. Then we have the safety standard 61730, so safety qualification for module construction. Then also you have the installation standard AS/NZS 5033, which has some information about bifacials and instructions. And then lastly, there is IEC 60904. This is just a special standard for purely bifacial photovoltaic characterization. So let's just unpack them a little bit. Starting with IEC 61215. Now, clause 11.11 mentions that there is 2 new irradiance conditions to represent bifacial modules. Elevated current for the module quality tests. So these are, one being the G, which is irradiance of BNPI, and this is equivalent to 1000 watts per meter squared, which is obviously the STC front irradiance condition, plus this numeral, or this symbol, which is representing bifaciality factor, multiplied by 135 watts per meter squared. So that's for BNPI. We touched on BNPI earlier, bifacial nameplate irradiance, and this value is 135 watts per meter squared on the rear side. Now, the second one is GBSI, which is the irradiance at the bifacial stress irradiance. And the stress irradiance is at 300 watts per meter squared, so a very large rear irradiance level, and this representing the most extreme case. So this is also outlined in clause 3, where it just explains the abbreviations of these two and what they mean. And in appendix A.2, it gives the procedures for bifacial modules now that they see fit, and also explains why 135 watts per meter squared was actually utilized as the BNPI value. And the reason was because after reviewing and assessing several published studies online throughout the world, and they found with the typical conditions of, what we discussed already earlier with the factors that influence bifacial gain, like spacing, albedo, rear side irradiance, was shown to be in the range between 100 and 150, and therefore they have settled on 135. And BSI is the more extreme case, as I mentioned, 300. And this is, as you'll see shortly, used for sizing, current protection equipment devices. So OCP and stuff like that. Clause 11 is just detailing some, updates or additional requirements to some of the MQTs, the module quality tests, to take into account the bifacial modules, because naturally now they have a higher operating current in the scenario where there is, irradiance on the rear side. Now, going on to the safety standard, 61730, they obviously updated some new requirements to take into account the bifacial modules on the market, right? So now they want us to measure and report and label the VOC, ISC, Pmax, and all other characteristics at STC, which we already do, plus BNPI. And also the nameplate should include bifaciality factor for VOC, ISC, Pmax. Now, for your information, the bifaciality factor for VOC will just be 1. As we know, the module's ability to generate current is linearly proportional to the irradiance hitting it. However, for voltage, this is not the case. there is no linearity, proportionality, between the voltage output and the irradiance. So whether you have 1,000 watts hitting a panel or 100 watts, the voltage will still be the same. You can test this yourself with the multimeter, and you can look at it yourself when you review the data sheet's IV curves. You can see that they give you IV curves for all the different irradiance levels, ranging from 100 to 1,000. The current drops linearly, progressively, but the voltage is pretty much in the same value, whether it's around 38, 39, 40 volts, something like this. So that's why, if you measure the voltage when the rear is facing the sun versus the front, it will just be the same. So it's 1. But as we know already, for current and power, it's going to be dependent on the technology. So we know it's 0.8 for TOPCon. And clause 6.2.2.1 just shows you a sample label of a random panel, or what a panel should look like for bifacial labeling. And then you can see the Suntech one in the bottom right-hand corner. So that's what our future labels will look like for the 2021 stamped IEC products. Also, there is some more snippets that I put in here, which detail some more info. If we look at clause 6.3.4, they have mentioned that you should be calculating your rating for your overcurrent protection devices as 1.4 multiplied by ISC. This is normal for normal panels. Now we have bifacial. So they want you to do 1.4 multiplied by the ISC at BSI, which is bifacial stress irradiance. And you can see it's quite simple because the manufacturer will now print this on the data sheet in the future. So in Suntech's case, let's look at it together quickly. So the STC short circuit current is 14.41 amps. Yep, we already know that. But now at BNPI condition, it is 15.97 amps. And then at the BSI condition, it's 17.87. So you can see the progressive increase in current as there is sunlight on the back with the BNPI and BSI. But for reference, just to reiterate my point about voltage being unaffected, you can see that at the voltage, the VOC at STC or BNPI is pretty much the same, around 38, 39. Now, in the AS5033, it's pretty short and sweet. It doesn't really detail much info, but the only relevant one are these two here as follows. Clause 3.3.3.1a is giving you the formula to calculate the maximum string current for the array. So historically, it's simply 1.25 safety buffer multiplied by short circuit current of the module. Simple. But now with bifacials, there is just one more factor you have to multiply, which is this K factor. This K factor is described in Appendix J, and it's simply the enhanced bifacial current divided by the normal STC current. So we already, have an idea how to calculate this now, because even in the new data sheet labeling, they'll give you the enhanced current at BNPI or BSI, and you just divide that by the normal current, and that's your K value. But another way to interpret the K value is just simply 1 plus bifacial gain. So if your bifacial gain calculated, whether it's through manual calculation, whether it's through software, whether it's through a third-party case study, empirical data, your K value will be 1.05. Hopefully that makes sense. So you can see your calculated string maximum current will be that little bit higher because of this bifacial gain. And the last standard that I mentioned that referenced bifacials is the test specific standard for bifacials. And this basically outlines a test procedure to characterize the bifacial module in terms of the bifaciality factor. And also they do tests at varying levels of rear side irradiance from as low as 25 watts per meter squared all the way to 250. And it gives you the respective voltage, current, power, etc., etc. So this is good for sending it to developers or EPC contractors who want to just verify the performance output of your bifacial panels. All right, let's review this chapter together. So please get ready for this next round of 4 questions, and give you a few seconds and we'll get started. All right, let's go. How many different standards have published clauses containing relevant information about bifacial PV modules? 3, 2, 1, and let's see. Correct, guys. You're really quick learners. Great job. Next question. What does BNPI stand for? That's it. Let's see. Majority answered A, bifacial nominal power index. Sounds right, but is it really? Let's check. No, in fact, maybe this one was overlooked by you guys. So it's bifacial nameplate irradiance, simply. According to IEC 61215-2021, what is the irradiation value on the rear side that IEC has deemed appropriate to be used for BNPI? And good job, guys. C is correct, 135. All right, last one for this chapter. According to IEC 61730, what label rating method should manufacturers use to print their bifacial characteristics? Perfect. So almost majority scored B, which is correct. Well done, guys. All right, now moving on to software tools. So this is more, the first 3 chapters, guys. Sorry if it's overwhelming, a little bit technical and theoretical stuff. This is probably more relevant to your everyday activities. So let's talk about some software tools in the field. Going from left to right on this slide, I'm just demonstrating from lower complexity to higher complexity of bifacial modeling for PV modules. So there's 3 different methods that are available right now to kind of model rear irradiance, how much is hitting the rear surface and consequently how much bifacial gain. So the most simplest method is empirical model. And this is simply a bunch of vendors, whether it's laboratories, researchers, manufacturers, including us, releasing case studies of specific systems with setups, specific setups, and giving the resulting bifacial gain. So this is one good way if you see any case studies which have pretty similar setup to your system, you can simply take their output results as your representative of what your bifacial gain might look like. Secondly, there is a view factor models. View factor is using simply a mathematical 2D geometry to kind of calculate the resulting irradiance that's available on the rear side. So it takes into account a lot of things, the irradiance that's available, your site conditions, and sees how much of the ground sees sunlight, how much is shaded by the panel, and does the geometrical 2D calculations to quantify the rear irradiance. So a couple of vendors do this one, including PV Syst, Rated Power. My mistake, I should include Helioscope, Pylon, Opus Solar. They don't do it. But yeah, again, PV Syst, Rated Power, Sam from NREL does it, PV Sol. And the last model is ray tracing model. So this is basically quantifying and simulating every single ray of quantum sunlight and measuring the respective irradiance that can hit the rear side plane. And even the softwares that use this method is calculating the power output per cell even to this level of precision and accuracy. So this one is very complex and therefore high computing power. Just like mining Bitcoin, this one uses a lot of mining computing power. So it can take up to whether a couple of minutes to a couple of hours to do this simulations. So I wanted to, on behalf of my fellow solar colleagues, do some tests and use all the different softwares to see what they're yielding in terms of the quantifiable bifacial gain. So first I set up a control system with these parameters. So specific location, size, roof type, albedo, azimuth, ray tilt, etc., etc. and I used our NSH-TB Plus to present the bifacial system simulation, and I used the NSH-M to represent the monofacial system simulation. Let's see the results. So first, I used Pylon. So you guys are familiar with this software. It is, very cost-effective rooftop solar design proposal software. It's like $4 per simulation, something like this, and it's quite popular. So I tried to check it out, and unfortunately, monofacial annual yield was 73,000, and the bifacial one was also 73,000. And this therefore concludes that it uses no active bifacial model method. So you cannot rely on this software for bifacial modeling. Next software, which was Helioscope. This is a bit different to Pylon. It's more of a monthly subscription fee and a little bit more expensive, more for enterprise grade companies or EPCs, stuff like that, and also popular for CNI projects. Anywho, I did the same test with the same product, same control system parameters, everything. And unfortunately, both monofacial and bifacial yielded the same output for the annual yield of 70,683. So again, even these guys publicly listed on their website that they're not using any mathematical model to simulate bifacial gain. So that concludes that. So far, Pylon and Helioscope, no. Next, I tried OpenSolar. This is free to use to the public and based on a manufacturer contribution royalty to keep them to use their revenue stream. Anywho, there was a slight difference I found in this one actually, and basically the monofacial was 73,177 kilowatt hours per year, and the bifacial was 74,285. So very small, but still something, and it shows that there is some sort of mathematical model going on. And I could verify this because they did ask for some parameters that are relevant to bifacial gain influence, right? So like spacing, like the ground coverage ratio, and the bifaciality factor as well of the module they asked for when I was inputting the inputs. So yeah, OpenSolar does yield some difference there. Next up is SAM, System Advisor Model, created by NREL, open source platform developed by all the smart minds there. Free to use to the public as well. It's a desktop application, so you don't have to go online. You can download it and it's available offline forever. Anyway, this one is very accurate because it does have an active bifacial gain model. And it was obvious because in the module selection part, it asked me to input if the module is bifacial. Then it went on to ask me for transmission factor, which is that transparency factor I talked about. It asked for bifaciality, ground clearance, albedo, etc., etc. So it asked for all the right things, basically. And in the end, you cannot see it, but I'll read it out. The monofacial system yielded 84,174. The bifacial yielded 90,017. So this is about almost 7,000 kilowatt hours more per year with the bifacial system. So this is, successfully computed the bifacial gain. Next up is SunSolve, and this one is, paid subscription based on membership, and it's using ray tracing model. So this one took maybe 10 minutes to actually simulate, so it took very long. And in the end, it did yield there was a delta between the two annual yields between monofacial bifacial, and it was in the order of also a couple of thousand kilowatt hours. So that's great to see. So in summary, Pylon, Helioscope, there was no bifacial gain displayed, and therefore these software tools are deemed not suitable to realize the bifacial gain. OpenSolar, it showed a 1.51% gain in those two simulations between the bifacial and the monofacial. So this one perhaps is not accurate, but it is still deploying some sort of model. So hopefully OpenSolar can build upon that or make it more publicly available what their methodology is, so we can have a better understanding and see if it's really accurate. System advisor model yielded the highest difference. So whether this is true or whether this is not true, it's still, promising to show that there is a difference based on the inputs we put. So it was almost 7% bifacial gain for these two systems. And SunSolve, the ray tracing one, which is supposed to be the most accurate one, yielded 3.4% yield gain. So all in all, I think definitely SunSolve probably the most accurate, so it's best to rely on that one. However, for the purposes of proposals, it's nice to show SAM as a method of showing the bifacial gain. Perhaps there is some assumptions in SAM that makes it a little bit different to SunSolve's results. But anywho, this is just for your reference, guys, and you can play around with it yourself and see how you go. All right, next round. So let's see how we go with the next 4 questions on software tools. All right, let's get started. So which bifacial modeling method strikes the best balance between accuracy and practicality? So ray tracing is the most accurate, correct? However, the correct answer truly is view factor because of its around speed for simulations. It's very practical for the everyday installer or a rooftop application system advisor. Which popular solar software platform listed here does not support bifacial modeling? This one should be quite straightforward. Hopefully everyone gets it right. Correct answer is D. Now, I didn't present on PVSys because I couldn't get an account. Apologies about that. But PVSys is primarily a solar farm software tool. So you'd hope that have bifacial gain modeling, right? So yeah, the answer is helioscope, as we saw in my study. Did not have any model available. Next question. Which software is free and best calculates bifacial gain? So free is important. This is why I came up with this question. Correct, guys. The answer is B, SAM. So System Advisor Model. It's not a very nice interface. It's pretty hard to use, probably for the beginner. However, as you use it more and more, you wrap your head around it, and it's perfect to work alongside your existing design proposals to provide the model for energy yield estimates. So I wouldn't use it as your primary software tool, but it is addition to your arsenal of tools to use, especially for bifacial gain calculations. When using bifacial modeling tools, what are the common input parameters needed? Yep, everyone is spot on. Well done, guys. So it's quite obvious now at this point of the presentation, all of these factors are important. All right, guys, so we're moving on to practical instances of bifacial module studies. So this study by UNSW, SunDrive, ANU, all very highly regarded institutions, have done a study specifically on rooftop solar flat roof system bifacial simulations. So this is very unique, actually. Everyone is doing simulations on the ground mount or laboratory. This is relevant to rooftop systems. And the key message here is that actually, because of the natural elevation of the modules is not that high, maybe a couple of 10s or 20, 30 centimeters high off the ground, the distribution of radiance is actually higher at the top of the panel compared to the bottom, because the bottom of the panel is kind of shading itself a bit, right? And the top of the panel can see more sunlight. So, but this doesn't really affect modern day technology panels thanks to half-cut cell circuitry. As you know, the top half and the bottom half are independently, operating in the panel because of their parallel circuit arrangement. So this does not put any additional stress on the panel, don't worry. And this distribution of irradiance also doesn't affect the energy yield either. But it's just worth noting. And this is also another study in agreement with this conclusion that the top of the panel sees more sunlight than the bottom in a typical roof mount flat roof system. Now I want to present some case studies or empirical data from different countries around the world done by TUV Rainland. And basically, they're all similar systems with similar mounting arrangements, similar height above the ground, similar tilts, and all of them just differ in terms of the location and albedo slightly. So you can see this system in Germany is showing around 11% gain. This one in USA, 8.2%. Then there's one in Saudi Arabia showing 12.7, and one in India showing 22.4. So very, very high gain there. And the explanation for this is simply, if you refer to the albedo value for this particular one, it's pretty high. It's 0.5, while the other ones are in the range of 0.28, 0.3. So you can see how powerful the albedo factor can be in dramatically increasing your bifacial gain. And here's another study just comparing fixed tilt to SAT, single axis tracking. And generally, they do conclude that the single axis tracking is a little bit better for bifacial gain. I mainly think this is because the ground elevation is a bit higher, plus the mounting system is a bit less obstructive, I believe, compared to fixed tilt, because it's just simply a torque tube, and that's pretty much the only obstruction, right? But with fixed tilt, you've got all the different cross member rails and can cause a lot of self-shading on the rear side. And here's some further case studies from reputable entities like Nextracker themselves, Tracker Company, PVEL, famous test lab, NREL, famous academic body in the industry in USA. So all these guys are pretty much in agreement with each other for different for tests with the same setups. They're seeing similar bifacial gains. All right, so now I'll run you through some tips to navigate the rooftop market with bifacial modules. So this formulation here is just helping you, giving you a quick desktop calculation, how to compute the adjusted power of a bifacial module given a certain condition. So adjusted power equals nominal power or nominal front side power multiplied by 1, because you're just including the normal power, plus this incremental increase from the rear side, which is bifaciality factor multiplied by rear irradiance on 1,000. So this little term here can be represented as a whole as bifacial gain. And hence I put this in the second line. So bifacial gain is simply bifaciality factor times rear irradiance on 1,000. And this is, this formulation is proof that the bifacial gain is, linearly, the power output of a module is linearly proportional to the irradiance. And we're just including the bifaciality factor here because we know, as we learned, the back is not as good as the front in generating power. And this leads me to the diagram at the bottom here, which just simply showing you that a situational bifacial where you have 1,000 on the front and 200 on the rear is equivalent pretty much to 1,160 on the front for a monofacial panel. The reason for this is we do 1,000 plus 200 times 0.8 in this case, which is the bifaciality factor. We don't just add them together and that's it, because we know the back is slightly lower in terms of generating power compared to the front because of the bifaciality factor. So yeah, this is what this illustration is trying to demonstrate. And to bring the point home, we'll just do 2 examples quickly together. First one is calculate the percentage increase if the expected highest rear irradiance is 225 watts per meter squared. So percentage increase or bifacial gain, same thing, right? It's a percentage increase of the power. And we already learned that it's 0.8, so bifaciality factor, multiplied by 225, which is the rear irradiance on 1,000. And in this specific scenario, it's 18% bifacial gain, right? Now, using this knowledge, let's calculate the appropriate max input current that an inverter needs using a PV module with 0.8 bifaciality, a normal ISC or short circuit current of 14.41 amps, and 150 watts per meter squared rear irradiance. So first, we want to just compute the bifacial gain for this one, which is 0.8 multiplied by 150 on 1,000, right? So that's 12% bifacial gain or power increase gain. Then we learned from the IEC standard for bifacials or the AS1, AS5033 that to work out the new max short circuit array current, you do 1.25. So already aware of this safety factor multiplied by the K value. And the K value in this case would be 1.12 because it's 1 plus 12%. So 1.12 multiplied by 14.41, which is the normal current. So now the adjusted short circuit current for this bifacial gain is 20.174 amps. So you want to find an MPPT tracker, which has a higher max short circuit current than 20.174 amps. Now, what are we bringing to the market? So Suntech is proud to be distributing the latest innovations in TopCon bifacial product technologies in the form of our Ultra V Pro Mini. So we got currently C54 NSHTB Plus, which many of our valued loyal partners are deploying, and they're showing some great feedback so far. So this one is still in the very practical 1722 by 1134 frame, 21 kilograms. So, whatever your age or your strength, it's still quite practical. And bifaciality factor, of course, 0.8, we already know this. We also have a future product which is using a slightly different cell. It's a rectangular cell dimension, and therefore it's able to output a little bit more at 450, but as a compromise, it's a little bit longer and it's 21.5 kilograms. And this one is not all black. So yeah, these are the differences. And of course, Suntech is proud to be recognized by PVEL in their latest top performer reliability scorecard, of course. And just to remind you guys, we are a top 10 most bankable solar PV manufacturer in the world, as rated by BNEF, Bloomberg New Energy Finance. We have our testing body as VDE, which is a very famous testing laboratory in Germany to get all our certificates. Only one other premium manufacturer has the same testing body. Tier 1, of course, for many years, since 2014. Munich RE Reinsurance. So if you go on their website, Suntech is recognized by them as a reinsurance company, thanks to the bankability and product reliability recognized by them. And of course, all our range in C54 categories, 25 years product, 30 years performance. And nobody cares about the numbers these days as they've learned and been educated. So I want to reiterate, we are the longest standing manufacturer in Australia. We have the most experience in the market, and we have a very low failure rate, really strong product reliability, and as verified and contested by all our loyal partners, they agree with that. So don't listen to me, listen to them. Also, ESG is very important these days. It's a prominent topic in many stakeholders when considering a PV panel vendor. So Suntech is proud to know that we're recognized by EcoVadis with a bronze award for the sustainability rating. And we also have passing audit reports from SEDEX, which is a third-party British auditing company. So I thought I'd just give you up to date, bring you up to speed with Suntech and their latest achievements and accolades. Now in the C&I and utility segment, we have also these other product lineups, anywhere from 540 watts all the way to 710 in the form of these different categories, whether it's C72, H66, or D66 here. So guys, key takeaways, bifacial gain can range anywhere from 0 to 25% and depends on a myriad of factors as presented. However, the most influential being the albedo, or the grand reflectivity. And most modern design tools have not adopted a bifacial gain model and cannot capture this in the annual energy yield estimates, right? But tools like SAM and more complex ray tracing models can capture the gain estimate. The new standards have instructed manufacturers to provide reference bifacial ratings at BNPI. So if you're not sure, and based on this presentation, if you still can't gauge what your bifacial gain will be like in any particular installation scenario, then your fallback and your rule of thumb would be to use BNPI as a bifacial gain. Okay. And this area for bifacial gain modeling is still maturing, it's still new, and solutions are slowly being released for the rooftop scenarios because this was never considered before. But now all of a sudden, the whole industrial chain is bifacials. So naturally, it will be used in rooftops, and the energy gain capture will be more and more accurate and easier to compute as the time goes on. So as much as I try to capture and portray as much information about this topic as possible, it's not a complete research and definitely would be ongoing. So, watch this space and, please, keep up to date with our social medias to see what's the latest developments in this area, right? But yeah, bifacials, is already at the mainstream for a long time now, and soon it will be the market-dominated option on the market. So this is why hopefully this training is valuable to you. Let's conclude with the last 5 questions of today's webinar. All right, without further ado, let's begin. For typical flat roof tilt leg systems, what does the rear radiance distribution look like? Three, two, one. It's a bit of a long one, a tongue snapper. So hopefully you guys had some time. Highest at the top and gradual decrease to the bottom. That's the majority answer, and that is correct. Well done, guys. For empirical case studies shown by TUV Rainland, it shows 4 systems with similar installation conditions, similar tilt, ground elevation, and mounting arrangement. What is the parameter which causes the variance in bifacial gain to be as low as 8.2% to as high as 22.4%? Big variance here. Why? What was the differences? Majority answered albedo, and that is correct. Well done, guys. Question 19. What would be the bifacial power output of a module that is normally 620 watts with following conditions? Now, I haven't set a time on this one, so take your time, read it out loud, and answer whenever you're ready. I'll do it myself just to get a gauge on how long it'll take. So let's do it together. 620 watts. But it has bifacial 0.8 and rear radiance 150. So the resulting output will be I think that's enough time. So now I'll proceed to see what the answers are. All right, so we got A, B, C, D, and majority, is it still coming in? I think that's it. So majority answered C, 694.4 watts. Well done, guys. Absolutely correct. So if you use the formulation properly, this is the answer. Last one of the day. Thank you so much for your patience and apologize for going a little bit over time. Calculate the appropriate max input current for an inverter using a PV module with following conditions: 0.85 bifaciality, normal STC short circuit current of 16.7 amps, and a estimated rear radiance of 150 watts per meter squared. So just to give you a hint, 2-step process for this one. First, calculate the bifacial gain potential with the conditions. Then you can apply the AS5033 formula for maximum array current. All right. Hopefully that's enough time for you guys. I'll move on to see what the results are. And let's see. So majority answered 21.75. Let's see what the answer is. Answer actually is D. So maybe let's break it down together. just in case there's any misunderstandings. So first step is bifacial gain for this condition. So we know the bifaciality, yep, 0.85. And they've given a radiance level at the rear. So from these two values, you can simply compute bifacial gain by multiplying 0.85 with 150 on 1,000. So you get 0.1275. So this is 12.75% bifacial gain. Next, we use the formula to calculate max array currents. So it's 1.25 safety factor multiplied by the K value. The K value will be the bifacial gain plus 1, right? Because 1 represents a monofacial panel, and anything above 1 represents the multiplier for bifacial gain. And the multiplier we calculated was 12.75. So it will be 1.1275, right? Then you multiply by the normal current at STC condition, 16.7 amps. That yields 23.54 amps. So this one is a two-step process. Hopefully that makes sense. If you were to redo this using BNPI, the only thing you'd change is replace the 150 with the 135. That's it. All right, so let's just review the analytics for this quiz for today. So we got top 5 here: Steve, Adam, Johnson, Marcus, and Mike. Well done. You guys achieved very good results. I'll send you all a report of the total results for everyone. And I'm trying to see if I can scroll down here to see the hardest questions. Oh, it doesn't want to play ball. Okay. Anywho, so you guys did well overall. Thank you so much for your interaction for this. I think it was about 53 people in the quiz, so great job. And now I'll leave it on to the Q&A session, guys, if you've got any outstanding questions. Thomas, are you finding evidence of percent gains with flush-mounted systems? There hasn't been any literature or case studies on bifacial gain on flush-mounted systems. I think you guys will be the catalyst to report on this because you guys are installing systems in the field. And I must note, if you're doing like a solar edge or Enphase, you have a panel level monitoring as well to see, to give you a reference of the bifacial, monofacial. So perhaps you can do this test yourselves and give us the feedback. But so far there is none. But taking into account bifacial modules have transparency factors of 3% on average, then there is the potential for sunlight to go through the panel, reflect on the surface interface, come back, and this light can be generated into current. So that will be in the order of a very small percentage, but it will probably yield something. So that means if you have a flush mounted system and it's very light in color, potentially yes. If it's not, then I would say it behave very similar to a monofacial product. Second question, are your panels borderless? So our product series are all framed with the aluminum alloy. We don't deploy any frameless products. At the moment, we just deploy just the frames. And Thomas saying hopefully white roofs. Yes, I agree. So white roofs will be, I think, correct me if I'm wrong, but most new housing builds, whether they're using color bond or steel sheets or whatever the interface may be, majority of them are white. And I think for other reasons than just the manufacturing process or manufacturing supply chain of the roof materials. But I think there is an element of passive design and, it blocks a lot of heat to get into the house. Obviously white reflects, as we learned with albedo, and it goes hand in hand with reducing the heat load of the house. So it's a very clean, smart energy design to be a light colored roof. Yes, Steve. So basically the process will be I'll have an attendance report of this webinar and I have all the participation of all the people who did the quiz. And from there, I will issue out all the certificates to you guys who participated, and you should be able to redeem the points that way. So you got my email anyway, if there's any issues. So, feel free to call or reach out if you need some help. Deepal Shah, good to see you, brother. Thank you for joining us. How is 1.6 millimeter slash 1.6 millimeter glass to glass more durable than 3.2 millimeter glass on monofacials? How is it more durable? So currently, both the dual glass and monofacial are achieving and yielding the same Hale stress sequence results from the IEC standard. They're yielding the same wind load, pressure, results, and the standard ratings can be complied with for both. Mechanical stress sequence as well, that quality test passes both with the same results. So whether one is stronger than the other, I don't think so. They are both, obviously certified and compliant to meet the same quality tests. But however, both of them naturally both have 3.2 millimeter worth of glass, right? Because 1.6 is just divided by 2 to represent 3.2. Currently, our single glass range, though, does have Wind Region D certification. We haven't engaged with the third party again to do it for the dual glass, but if there is any sort of real demand for that, we can definitely sort it out and organize it. Rob V asked, are there any adverse effects from the hard shading on the rear from the rails? So I would say currently it's early days. There's not much evidence of that being a problem. However, as time goes on and more flat roof tilted systems are deployed with bifacial panels, we can see and we can study the data. From a technical, objective perspective, modules these days are very high tech. They have, first of all, many mitigation strategies to avoid issues um, with mismatches of irradiance, such as bypass diodes are now more reliable. There's 3 of them, distributing the panel into 3 different sections. There's also the new half-cut cell interconnection circuits, which is not only reducing the operating current per cell, but also splitting the top half and bottom half of the module independently, and the current carrying capacity of the electrodes on each half are independent. So yeah, this will not affect also the power output as well. So thanks to that, I think, yeah, it will not be an issue. Max has asked a good question. Plans for the weekend? Well, I'll probably hang out with some of my bifacial installer mates. Or maybe I should say monofacial installer mates, because I only have friends with loyal people and who don't talk behind my back. Uh, so yeah, maybe some more research and just enjoy the upcoming spring irradiance, right? Slowly getting out of winter. Ashwindra Narayan has asked, what size DC cable used with the bifacial panels? Is there any restrictions? Great question. So generally, 4 millimeters is more than enough for most array DC cables for your DC runs. But definitely with the increased current output capacity of the bifacials, you should reconsider this to 6. However, in most cases, as I said, it depends on your installation scenario. If you have a very small tilt, very small ground elevation, very small inter-row spacing, your bifacial gain may be of the order of only 1 to 2 to 3%. And if you want to size your cable up because of this, I think it's overkill. But again, you need to do it on a case-by-case scenario. How do they go near the beaches with salt exposure? Great question, Nate. So part of the reason for this industrial shift to dual glass is the added anti-mist corrosion properties of these products. So by replacing the traditional polymer backsheet with glass now, it is safeguarding the panel against punctures on the rear side, which will allow easily any sort of moisture, acidity, even alkalinity, And therefore, these panels are not only more corrosive resistance, but less prone to water ingress. Because the weakest link was always the back sheet for low insulation resistance failures, right? Because that's where most of the moisture can get through, whether it's through the perimeter or directly through the back sheet because of some damage it caused, or simply because of the deterioration of the back sheet due to extreme climate conditions and the manufacturer not having a high quality construction and materials. So again, it comes down to, of course, number one is pick a high quality manufacturer because they will optimize their materials usage, whether that be the encapsulation, the backsheet, the glass, etc., cells. Also, they will optimize the quality control and assurance of the product assembly. Then the second step is to identify the products which are more durable. So naturally, organically, dual glass are more reliable. And this is backed by certification too. So if you watch my recent video on the 440 dual glass bifacials that we're pushing, these come with test method 8 approved salt mist rated certification from the IEC 61701 standard. Traditional panels come with test method 6 only, so which is still good, but test method 8 is just to a much higher level, and these are much more suitable for coastal installations, definitely. Good question, guys. Thanks. Yeah, so Graydon Cox made a good point. So because the rear substrate is now glass, glass is, come on, it's much stronger than plastic polymer. I'd trust a glass, coffee table in my front yard in the sun for 20 years compared to a plastic coffee table, right? So naturally, the material difference is the major difference in the durability of the product. Thomas Dingenham asking a very relevant question. Which inverter systems are you finding can support those fault currents? Good question. So not only are short circuit currents getting bigger and bigger with new models, but also with bifacials, they have potential to get bigger. So therefore, I am compiling a list as we speak in real time of all the different inverter vendors and their models, which are having a value higher, max input current higher than our range, the mainstream bifacial range. So I'll release that. But so far, at a high level, I would say all the recent versions or variants of Sunny Boys are fine. All the recent Gen 3 single phase Goodwies are fine. All the recent, actually, I haven't checked Sungro yet, but yeah, so these two are what comes to mind. N-phase depends on which microinverter you're using, but definitely some of them will have a very high short circuit current of 25 amps, which is plenty. So yeah, you just have to check it case by case, but definitely there is not a shortfall of options. Yeah, correct, Thomas. Yeah, 25 amps ISC for Enphase. No worries, Laith. Murad, thank you so much for your time for visiting our webinar today. So, that's very heartwarming. Thank you, Doug, for your kind words. Graydon Cooks, bifacial mates. Maybe I start a trend, right? So this is an inside joke with me and you guys. Let's make some bifacial mates, or reduce the amount of bifacial mates rather. I think that's a more healthy option. Can we have a copy of this presentation and permission to share it? Can I run the simulation in Solar Plus and provide their bifacial comparison for you? Absolutely. Thomas, good question. So Solar Plus, I didn't try it. It's developed or co-developed by Glenn Morris's company. So that is probably really relevant to your industry, the industry. I've just pasted my email address in the chat box, Thomas, or for anybody else who's interested to reach out for any questions. You're welcome, Mark. You're welcome, Manikandan. Thank you, guys. Thanks, Nate. Robert Reed. Yep. Thank you for mentioning grow watts, 21 amps. That's very good. Appreciate all your kind words, guys. So again, got my email there. Feel free to log off now. And yeah, but anyway, reach out to me anytime. I need the accreditation numbers for all relevant installers who need to redeem the CBD points. And I will also confirm whether it's 20 or 30. And we'll go from there. So yeah, let's keep connected, and thanks for your participation, and see you in the next one. Cheers. And stick around if anybody else has any other questions. Also pop my phone number in the chat. I'm happy to share it with you folks. Thank you, Guy. I think we peaked at about 80 something participants in the Prezzo, and there was about 60 in the quiz. So yeah, the guys who missed out on the quiz, if you are an installer with a accreditation license, let me know, and I can redo the quiz with you one-on-one, so you can, verify your understanding and assessment, and then we can get the points ready for you as well. Robert, all you, my friend, you are the legend. Thank you so much for your kind words. So Robert is the head of sales for our partner at Go Solar, and yeah, they are also supplying bifacial panels. So if you have any questions about that, feel free to reach out to Robert. He's your man. Similarly, if you want a super all black 440 watt, that is not transparent. So transparency can be good and bad in terms of looks, because if you install it on a tilted system, then it doesn't look all black, because all of a sudden there's sunlight hitting the back and it loses that all black appearance. But if you really need to stick to all black, then I recommend the NSHB model, which is also available with our other great partner, Lawrence and Hansen. You can reach out to any members from their team if you have any questions for that product. All right, guys. So I think we'll just leave it there. If there's no more questions, I'll go ahead and leave to mark the end of this recording and webinar. So thank you again so much, and look forward to your continued collaboration in this fantastic industry, right? Cheers.